from the real numbers d and mu e to the power minus in tau minus sigma, and here we once again remind ourselves that this tau plus sigma is sigma plus and this is sigma minus. Okay, so that means this is our left mover and this is our right mover. So you see, keeping these boundary conditions in mind, okay, now we are at the moment considering only R sector, so that means we consider this at sigma equal to 0, this at sigma equal to pi. And accordingly, we can choose for the left mover these are the left movers, psi plus, and these are the right movers, okay, in our definition. Okay, so, and these are going to be our standard annihilation operators. So d and mu, if you take the reality condition on psi mu is also real. Okay, so d and mu is, so these are the creation operators. So creation operators are d mu of minus and or d mu n of Daya, Hermitian adjoint of this. And obviously the annihilation operators would be d and mu. So these are the annihilation operators, and this times this would be the number operator. Okay, a dagger a. So this times this. Now what happens to the other choice? Which means we remove this and we keep this, and thus the NS sector. So in the NS sector, the Fourier modes would be psi mu plus at sigma equal to psi mu plus tau sigma. This is 1 upon square root of c 2. This is R plus 1/2. So this is VR mu e to the power minus IA R tau plus sigma. So this is sigma plus. So these are left movers, and psi mu minus tau sigma, this is the same, and this would be VR mu e to the power minus IR tau minus sigma. This would be sigma minus, and so this would be right movers. Okay, so I have two different expressions, one for the left mover, one for the right mover. Okay, and both of them would make our boundary terms vanish. Okay, so fine, and I would be using m and n from the real numbers, and I would use rs for the fractional numbers. Okay, half integers. This m and n for integers, and this for the. So here again you would use the reality condition. Reality of psi mu would mean Br mu dagger would be b minus b mu of minus r. These would be the creation operators. Okay? And obviously the annihilation operators would be Br mu would be annihilation operators, b minus r of mu would be the creation operator. Okay. So, and then let me also, so open strings would be taken care of by these in the two different sectors. We would now always talk with respect to R sector or NS sector when we talk about open strings. Okay, and what happens to the closed strings? In the closed strings, psi mu of plus minus of psi mu plus minus sigma and tau. So for closed string, what can we have? We can have either periodic or anti-periodic boundary conditions. Okay, so this with plus sign, this is periodic boundary conditions, and with minus sign, this is anti-periodic boundary conditions. Okay, so we can have either plus or minus. Okay, and this in the literature, you have two quantum numbers. For me, one quantum number would be enough, whether these boundary conditions for closed strings are periodic or anti-periodic. But they call periodic boundary conditions are usually referred to as the Ramond boundary conditions, and anti-periodic boundary conditions are usually referred to as the Neveu-Schwarz boundary conditions, or we call it R sector, NS sector. Okay, so just to make you familiar with the conventional vocabulary. Okay, but one of them is periodic, one of them is anti-periodic, and accordingly you have different kinds of so psi plus mu of tau sigma. This for periodic boundary conditions. This is an real number. This d mu and tilde have nothing to do with the earlier d mu. Okay, I'm just use different symbols. So this is not has nothing no relationship whatsoever with the d mu n of the open string. Okay, so this e to the power minus twice I n times tau plus sigma, and this I always prefer to write to remind us that this is sigma plus. So it means I am writing two big letters. Let me be a little bit small. So this is anti-periodic and periodic boundary conditions. Okay. So then this would be my left mover, and I can have psi plus as this equals to mu tilde r tau plus sigma. This is also left over. So this or this. Okay, this corresponds to the periodic, and this corresponds to the anti-periodic. So this, and as I said before, this r would be a half integer. Okay, r would take half integer value, 1 half, 3 half, 5 half, and so on. Whereas n would take integer values 1, 2, 3, 0, 1, 2, 3, and so on. And both of them are left movers. One for the periodic, one for the anti-periodic. Similarly, I am going to have two more. So one for the periodic, one for the anti-periodic. Here I have psi minus mu tau sigma is d mu n times e to the power minus twice I n tau minus sigma, so that this is sigma minus, so that this is the right mover, and I would have one more condition, one more choice, psi minus of mu tau sigma, and from z plus 1 half b r mu e to the power minus twice I r. This is, so this is also right. Okay. If you like, one could call this as the R, then this would be an S. This first one, if you call as R, this you would have S. Now, with these choices, what is possible? Our boundary conditions, boundary terms, special boundary terms, they remain the same, okay, and we have to make them vanish. Our aim is that. So you can have 4 different combinations: this with this, or this with this, or this with this, and this with this. So R with R, R with NS, NS with NS with NS, NS with R. So if you take this kind of pairing, so you